Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 14.5, day 2, entitled Descriptive Statistics. And today we're going to finish talking about the last two objectives. We're going to talk about variance and standard deviation, and then we're also going to talk about 5-number summary and specifically how to make a box plot. So when we're talking about measures of spread, we talk about two kinds. And the measures of central tendency that we've been talking about, like the mean, median, and mode, they identify the center or the typical value of a data set. But measures of spread or measures of dispersion can describe the spread outness or the variableness or the variability of the data around that central value. And that's important to know because if you look down here at this example, they have two sets of data, and both of these sets of data have a mean or an average of 72. But you can see that this set of data on the right is a lot less spread out. They're all grouped between 71 and 73. So that data set is all kind of clumped together. The data set on the right goes from 50 all the way up to 93. So that's got a much bigger spread or a range. And that can be important when you're analyzing data. Depending what this is, this could be the scores on a test. So if you have scores that range from 50 to 93, that says that you have, some kids that are really prepared and some that aren't. If the average is all around the same, that could tell you that, well, all the kids are doing pretty well on the test, but still their scores are only in the 70s. Okay, so there's a lot of different information that can be interpreted from this type of measure of spread. So let's take a look at an example here, and we're not actually going to do this actual example where we work it out. We're just going to read it and take a look at it because this would be very tedious if we were actually going to do this. But you have two machines that are used to fill 16-ounce soda bottles, and you want to test how consistently each machine fills the bottles. So a sample of 20 bottles a sample of 20 bottles has been taken from the output of each machine, and we want to find the standard deviation for each machine because that'll tell us how much spread there is between how many ounces each machine is putting into each bottle. Okay, so we have the soda machine 1 that we're going to call X, and then the soda machine 2 that we're going to call Y. So here we've got 20 samples for each. So if we want to, I think I've skipped something here. Yeah, I did. Let's go back to this because this shows us the actual equation that we have to use for standard of deviation. And that's what we're going to have to do in example 7, which I'll go back to in a moment. So we're going to talk about variance and standard deviation. Okay. So when you've got a bunch of data points, they label them x1 through xn. Okay, n is the number of data points. So in our equation here for the standard of deviation, which this measures how spread out the data points are, we're going to take 1 over n, so 1 over the number of points that we have. And then we're going to find the sum. And the sum is going from the first data point to the last. And we're basically taking that data point and then we're subtracting the average. It says up here that the x with the line over it, that stands for the mean. And then we're going to square it. And then we're going to do that for however many data points we have. So for this example here with the soda machine, we'd have to do this 20 times. We would have to take each amount and we would have to subtract it from, or subtract the mean from it, and then square it, and add them all up. So we'd have to do that 20 times and add them all up, and then divide by how many we have, which is 20, and take the square root. Okay? So this is a pretty complicated formula, and if you have a big data set, it's really cumbersome. Your calculator can do this for you, but again, you have to put the information into the calculator first. Okay? So this is a little symbol here for variance, or I'm sorry, for standard deviation. And the only difference between standard deviation and variance is that for variance, you square it. It's the square of the standard deviation. Okay, so in order to find the standard deviation, like we're going to do here, in order to find out how spread out these samples are, we actually need the mean. So that's the first thing that we would calculate. So the first step would be to find the mean for each of the soda machines. So here again, they're showing that they're adding them all up and dividing by 20. So this is our mean for that first soda machine. And then for the other data set, you add them all up and you divide by 20, and that's the mean for the second soda machine. So if you were just looking at that information, you think, hey, these machines are exactly the same. They're performing exactly the same. I see no reason to modify them or change anything. But if we go through that data set of the 20 samples for machine 1 and machine 2, and we find our standard deviation, here again, we're taking each set, or each point in the data set, and we're subtracting that mean and then squaring it. And we have to do that for every single value in our data set. And then we add them all up and divide by 20, and then take the square root. So for the first machine, we have a variance of 0.15. That means that the average, and I'm going to kind of use that term loosely there, the average spread between the numbers is 0.15. Now for the second machine, the spread between the data set, or the points in the data set, is 0.32. So that's a lot more spread out. So that means that there's a bigger spread. There's more variety or variance in the soda machine 2. So actually, soda machine 1 is more consistent when it's filling the bottles. So again, even though these machines have the same average, the machine 1, its samples are more clumped together, so it's more efficient. It's filling them more equally every time. For the second machine, since it has a bigger standard deviation, then each bottle has a bigger difference between how many ounces are being filled into each bottle. Okay, so that's what you would have to do on homework if they were asking you to find the standard deviation. You would actually have to substitute that in and do that work. Now, hopefully the problems in your homework aren't going to give you 20 data points, but if they did, you'd have to do that meticulously. You'd have to go through and find the mean, and then you'd have to take the data point and subtract the mean from it, square it, add them all up, divide by how many you have, and then take the square root. Okay. Now the 5-number summary and the box plots, these all go together. And these are pretty common forms of statistical analysis here. And you have already talked about minimum and maximum a lot in your mathematical careers. You know that minimum is the smallest number, maximum is the biggest number. So a simple indicator of the spread is the location of the minimum and the maximum. So that tells us the range. If we subtract the two, we can tell how much of a range we're dealing with our data set. Okay, and then we can also break that information down into quartiles. So 4 little pieces there because it's got the quart, like a quarter. Okay. Now, when we do that, we're actually going to take our number or our data set, take all the numbers, and we're going to put them in order. And then we're going to find the median of the whole set. And everything lower than that is going to be called the first quartile. And everything above the median of the whole set is going to be called the third quartile or the upper quartile. And then we're going to find the median of each of those. So we're going to be finding 3 medians. So you're going to have all of your points in order. You're going to find the median of the whole data set. And then you're going to take the lower quartile and the upper quartile, and you're going to find the median of each of those. and the median of the lower quartile is called the first quartile, or quartile 1. The median of the upper quartile is called the third quartile, or Q3. And the median of the whole data set is actually called Q2. Okay, so we'll talk about that more in just a moment here when there's an actual picture of it. So we're going to take those 5 pieces of information, the minimum, the maximum, the median of the whole thing, and then the first and the third quartiles, and we're going to put them together and call that the 5-number summary. So in the directions in your homework, they might say find the 5-number summary for this data set. So this is what they want you to do. And we're actually going to graph these in our box plots. So it's all connected. But you find your minimum and your maximum, and then the median of the whole set, and then the median of the lower quartile, and then the median of the upper quartile. Okay. So if you look at that in a picture, here this figure shows how these 5 numbers are related for a data set. And again, everything's listed in order here from smallest to largest. So we can see our minimum and we can see our maximum. So we can find our range for the whole set would be 30. And then we can find our middle value. We can find our median. And we have an odd number here. So the number below it and the numbers above it, you have the same amount. We have 6 above and 6 below that median. So we have a true median here, where we have a true middle number. So that median is actually going to be referred to as Q2. Okay? And then this lower half, this is your lower quartile, because it's everything below the median. And these numbers here, this is going to be your upper quartile, because it's everything above the median of the whole set. So then if you're trying to find the median of that lower quartile, we would take our 2 middle numbers here, add them up, divide by 2, and it would actually be 3 for our first quartile value. So that's the median of the lower quartile. And then if we take our middle numbers here, we can add them up and divide by 2, and we'll get 18. So that would be the median, or I'm sorry, the third quartile. So that's the median of the upper quartile. So those are going to be our 5 pieces of information that we're going to use over and over. We're going to have our minimum, our Q1, and then our median or Q2, and then Q3, and then our maximum. So seeing it in an actual example, I think, makes a little bit more sense. Now the other pieces of information we're going to find is going to be our range. So range of the whole set is just your maximum minus your minimum. And then we're also going to have this new one that's called the interquartile range. And this can help us find outliers, but it's basically just subtracting that Q3 value and the Q1 value. So you're finding how far those medians of the upper and lower quartiles are from each other. Okay, so here again, if we look at the same data set, it says that the range is 31 minus 1, which is 30. So I mentioned that earlier. But then it does show that our Q3 value is 18, and then our Q1 value is 3. So if we subtracted those, that's 15. Okay. And this data set is pretty nicely balanced here, but when you have a data set that's maybe more clumped to the left or clumped to the right side, like you have more smaller numbers or more bigger numbers, that's called skewed. You can have skewed data, and we'll talk about that in the next section. But that's one of the observations that doing this 5-number summary and a box and whisker plot can help us interpret. Okay, so let's take a look at another example here. And here we have a list of the HDL, the good cholesterol levels, for 17 males and 13 females who participated in a health survey. So we're going to find the 5-number summary. This is what it's going to say in your homework too. Find the 5-number summary for each group and then compare them and make some observations. Okay, so we want to find the minimum, the Q1 value, the median, the Q3 value, and then the maximum. Those are going to be the 5 numbers in our 5-number summary. Now I'm going to go to the next screen because the first thing we have to do is we have to take all of our male data and all of our female data and we have to put them in order. So that can be a little tedious to actually write out, but it's a necessary step because if we're going to find our middle values, our medians, and our ranges, we're going to have everything in order just so it's easier for us. So the smallest male value is 29. We had a couple 29s, so I'm going to list them each time. And then we have a couple 30s as well. And then there's a 31 and a 32, and then 34 and 36. 41 comes next. Then we had a couple 42s. We had a 44 and then a 46. And then we jump to the 50s and we have a couple 52s. And I have to go off to the edge a little bit here. And then we had a 55. So that's all of our male data put in order from smallest to largest. Now, conveniently, we have an odd number, so I can find my true median value, and that's going to be my 41. Okay, so that's my median for the whole data set, or Q2. Okay, so then everything from 36 down to 29, that's going to be my lower quartile. Everything from 42 up to 55, that's going to be my upper quartile. Okay, so 29, that's going to be my minimum, and 55, that's going to be my maximum. So now the hard work comes when we have to find our quartiles. Okay, finding Q1 and Q3. And that's going to be the median of the lower quartile and the upper quartile. And if I look here, I don't have a true middle number, so I'm going to have to take these two middle numbers, add them up and divide by 2. So my Q1 value is going to be 30.5. And the same thing here for my upper quartile. My two middle numbers are the 46 and the 50. So if I add them up and divide by 2, my Q3 value is going to be 48. Okay, then I have to do that same thing with the female data. So again, when you have big sets, this can be a little time consuming, but it's easy. It's easy to put numbers in order. And just remember that if you have more than one number, write it more than one time. We want every data point to be accounted for. And we had fewer females in this study. So there we go. There's our list of the females all in order. And again, I have an odd number, so I can find my true median value. And that's going to be right here in the middle. So my median value is going to be 53, or my Q2 value. Everything lower than that is going to be the lower quartile. Everything bigger than that is going to be my upper quartile. And I should have the same number in each. I've got 6 in each. Okay, here I had 1, 2, 3, 4, 5, 6, 7, 8 in each. I had 8 below and 8 above. Okay. And then I have to find my minimum and my maximum. And that's pretty obvious. Okay, 46 is going to be my minimum. And 60 is going to be my maximum. And then I have to find my Q1 and my Q3 values. So again, I'm going to take my two middle numbers here, the 49 and the 50, and I'm going to add them up and divide by 2. So my Q1 value is going to be 49.5. And then for the upper quartile, again, I'll have to take the middle numbers, the 55 and the 56, and I'll have to add them up and divide. So my Q3 value is going to be 55.5. Okay, so that's all of my 5-number summary values for the males and for the females. And now I also have to make some observations. So if we look here, we can see that our medians Our middle numbers are very different. Okay, the females have a higher median HDL level than the males do. We could also find the ranges too. That's probably one other thing that we should find. The range for the males, let's see, we're going from 55 to 29, so that would be 26. The range for the females is going from 60 to 46, so that's only 14. So the females have a much smaller range, so that means that their data values aren't as spread out as the males. So if you're a doctor and you're looking at this data, that's an important observation that males have a wider variety of their HDL levels. Women seem to have levels that are a little bit more clumped together from the mid 40s up to 60. Okay, so that could be beneficial or harmful. I don't know. I'm not a medical doctor. The other thing we should probably find is the interquartile range, okay, for the males. So that's where we take our Q3 minus our Q1, and that for the males is going to be 17.5. And then the IQR for the women, the interquartile range. So we'll take our 55.5 and we'll subtract our 49.5. And again, that's a lot smaller. That's only 6. Okay, so that means that there's less variability in the data points for the women. Okay, so there's lots of different conclusions that we can make from this information. Here's some that the book has listed. Here they show the information for the 5-number summary, and then for the ranges and the interquartile ranges. So that's the same values that we got. And then the book has some observations here. They observed that the median HDL levels for females was 53, which is significantly higher than the males, which was 41. But the female HDL levels show considerably less variability than the males, which is shown by finding the IQR. Okay, so they just listed 2 observations. There are plenty more that can be made. So you might have an observation that's different from what is in the book as well. So don't feel that if you write down an observation that it's wrong because it's not listed in the back of the book. There's a lot of correct answers here. Okay, the next thing, the last thing we have to talk about is a box and whisker plot. And your book calls them box plots. I have a tendency to call them box and whisker plots. But it's a way to graph the 5-number summary. And basically it's a number line, and you put the 5 numbers on there, and you draw a box around your Q1 and your Q3 values, and then you connect the boxes with little whiskers, little lines to your minimum and your maximum. Okay, so here's a picture of what a box and whisker plot could look like. Okay, here's your median value. Here's your quartile 1 and your quartile 3, so that's where your box goes, and you kind of draw a line there where the median is. And then you draw a little whisker that goes to your minimum value and a little whisker that goes to your maximum value. Okay, now this is just a random box and whisker plot. So if we did one, let's just say for the females, for that female data set that we were looking at, if we want to do a box and whisker plot for them, okay, we had to go from 46 to 60. So we could count by twos maybe. We could do 44, 46, 48, 50, 52, 54, 56, 58, and 60. Okay, so that's 44. I just started a little bit lower, and 60 went up a little bit higher. Okay, so 48, 50, 52, 54, and then I feel like I'm off here. 44, 46. Oh, this is supposed to be 48. Okay, let's see if the eraser works here. Sometimes it works and sometimes it doesn't. There we go. Okay, so we have 44, 46. This is 48, 50, 52, 54, 56, 58, and 60. Okay, so you're gonna just make your number line and make sure you go from your minimum to your maximum. And we're gonna put our median value, our Q2 value on there. and that was, let me do it in green here, that was 53. So 53 would be right here. And I like to make mine just right on the number line. Some people like to show it floating up above. It's just personal preference. And then for our Q1 value, we had 49.5, so that would be right about there. And then our Q3 value was 55.5, so right about there. Okay, so this is where you're going to draw your rectangle then. You draw that box, and then just draw your line through your median. That way we know that that's our actual median value. And then we're going to put in our minimum and our maximum. So my minimum was the 46 and my maximum was the 60. And then you just connect those with little lines so they look like little whiskers. So you have a box and then little whiskers like on a dog or a cat or a mouse or a bunny. Okay. Now what this actually does is it breaks up the information into 4 parts. Okay, and that's what the next slide is going to talk about. This is your first part. This is your second part, third part, and your fourth part there. So everything from your minimum to your Q1. So this was the minimum. This is your Q1. So that's your first quarter. And then everything up to the Q2. From Q1 to Q2, that's your second quarter. From Q2 up to Q3, that's your third quarter. And then from Q3 up to your max, that's your fourth quarter. And sometimes they're all evenly spaced, but in this one you can see they're not all the same size. Okay, so that can tell us information as well. That can tell us again how skewed our data is. And if this median value isn't exactly in the middle of your Q1 and Q3s, it's kind of off to one side or the other, that's an indicator of skewed data. It means you have more in one, well, not more, but you have more variance or less variance because you should have the same amount of data points in between here. Okay, so that's basically how you make your box and whisker plots. So they're pretty easy to make. And again, you should have made those in algebra. But if not, that's a quick review and we can answer more questions in class if you have them. But this is just some last minute notes here about the different quartiles. So when we're working with our quartiles, the median of the set is also called the second quartile or Q2, which we've had. So there's really 3 quartiles, Q1, Q2, and Q3. So we've already talked about the Q2. And it separates the data into 4 parts. So that was the 4 parts that I showed you. And we can actually break it down even more. So if you're really getting into some heavy statistics, you can talk about quintiles or deciles or percentiles. Percentiles break everything into 100. And we talk about that when we're talking about standardized test scores, if you're in the 98th percentile or the 67th percentile. And we talk about that with babies as well, like how much a baby weighs or how long the baby is, and they're in certain percentiles for growth. Okay, so you can get information from that. If you're up in the 90th percentile on a standardized test, that's pretty good. If you're down in the 10 percentile for height or weight for a baby, that's pretty not so good because it means you're small, you're itty bitty. Okay? So again, this is just another way that we can take this information and break it down into more and more detailed information so that we can make meaning out of it. Now, you can also do your box and whisker plots in your calculator, and the steps for doing that are on page 939 in your book. So that's how to do the box and whisker, the box plot in your calculator. And that's kind of a cool feature, and it's not that complicated to plug in the information because you're just plugging in the 5-number summary. So you do have to actually find those 5 pieces of information first to put them into your calculator, but then the calculator will graph the box and whisker plot for you. So that's kind of cool, and we can take a look at that in class. Okay, so there's not a lot of homework in this section because these problems are a little more time consuming. There's a little more detail for them, especially when you have to put everything in order and then find 5 calculations and then make a graph. Okay, but definitely practice this. The solutions are in the back of your book. They're worked out on the class website. And if you have any questions, come on in and see me before school.